Okay, today we're going to be looking at 7.3 and 7.4, which is functions and domain and range. So I have uploaded this sheet that you can print out for your practice problems, and we'll talk about it here in a minute. But first, I kind of want to do a little overview of what we're talking about. So today we're talking about functions. So I wrote up here the mathematical definition of a function, which is a relation, which just means a relationship like between two people. So a relation is two things corresponding with each other. But it's a relation from a set of inputs to a set of possible output where each input is related to exactly one output. Well, that sounds kind of really weird, but it really means whatever, you can only have one input. They have to all be different. And so mathematically speaking, what we're going to be talking about today is we're doing linear equations, and we're talking about lines and stuff. So we're talking about x and y. So the easiest definition would be that no x value repeats. And that's really all you have to worry about. Your y's can repeat as much as they want, but you have to have a different x value in every ordered pair in order for it to be a function. And so that really means, so if, say you have the number 5, whenever you put 5 into the equation, you can only have one answer that comes out. And so that's what makes it a function. So we're going to look at different ways that we're going to deal with this. And the first way is an ordered pair. So remember, we talked about an ordered pair last time, that in an ordered pair, the first number is always your x, and the second number is always your y. So here's a set of ordered pairs. So this would be the set of possible outputs and stuff. But what you're looking at is, this is your x, this is your y, this is your x, this is your y, this is your x, and this is your y. If all of the x's are different, which one, this one, they're all different, then yes, this is a function. So the instructions on your worksheet are saying, decide if it's a function, and then give the domain and range. So on your worksheet, you can just write yes. So yes, this is a function. And then you need your domain, what your domain equals, and what your range equals. So remember from before that domain is always your x values and range is always your y values. So these problems sound really difficult when you read the directions, but actually they're really pretty easy because your domain is all the x values. So my domain would be 2, 3, and 4. And they put them in these little brackets, which if you can't draw them very well, just do a little scribbly line, but it's called a brace. And then my range are all the y values, 4, 6, and 7. And so that's for that one. Now let's look at this one. Again, this is my x and y, my x and y, and my x and y. And so when I go to do the domain on this one, do you see I have a 1, a 2, and then the 1 is going to repeat. So as soon as I see it repeats, then my answer is no. Because the x value repeats itself, no, it's not a function, but it's still a relation. And so our domain is 1 and 2. You don't have to write 1 twice. If you do, I wouldn't count it wrong, but it's just easier to write 1 and 2. And then my range is 3. 3 repeats again, so you just have to write it once, and then the 5. Whoops, I did a parentheses when it's supposed to be a brace. So the y can repeat. It's only the x value that makes it a domain. So when we look at this last one, do you see my domain is 1, 2, and 3. Because there's my x, and there's my x. It did not repeat. So yes, it's a function. And then my range is 3 for every single one. And so for range, it doesn't matter. The range can have the same number on every one of them, and it still can be a function. It's only the x value that you have to worry about. Okay, so that's written as an ordered pair. The next way you can look at it is a Venn diagram. So when you see a Venn diagram, these are your x's and these are your y's. And so the arrow is pointing to what it goes to. So if you were to write this as ordered pair, this would be 1 goes with 5, 2 goes with 7, 3 goes with 9, and 4 goes with 7. Do you see that there's only one line coming off of each of those? So yes, this is a function. In my domain is all of my x values, which is 1, 2, 3, 4. And my range is all the y values, which is 5, 7. I keep doing parentheses. It's supposed to be a brace. 5, 7, and 9. But when you look at this one, do you see 1 goes to 4? I didn't really complete that. And 1 goes to 5. Do you see how it's got 2 points coming to that 1? So that means 1 is being inputted 2 times. So no, that's not a function. And then your domain is 1, 2, 3. And your range is 4, 5, 6. Sorry, I'm really bad at doing those braces. Okay, so a Venn diagram, you're just looking to see that the line only comes off of it 1 time. Another way you can look at it is in table form. So see here, do you see these are all your X's, these are all your Y's. So you look, does the X repeat? No, it doesn't. So yes, it's a function. And then I didn't leave myself much room, but just know this is your domain and this is your range, and you would list it out on your quiz or whatever, just like that. But when you look at this one, it goes 1, 2, 3, 1. Do you see the X repeats itself? So no, that's not a function. And the domain, I'll go and write this one out. The domain is 1, 2, 3. You don't have to write that 3 twice. And the range is 2, 3, and 4. And again, you don't have to repeat that 2. So I know those little, I'm sorry, I shook the table. The little bracket lines are hard to draw. Just do a little squiggly line if you have to. Okay, the next way you can look at it is by graph. So we've already talked about this graph, remember in 7.1. Any graph that's, a positive or negative slope is a function. So yes, this is a function, and I'll explain that in a minute. And the domain, remember, is negative infinity to infinity, and the range is up negative infinity to infinity. But the quickest way to do graphs is what they call the vertical line test. And so that means if you draw a vertical line anywhere on this graph and it only hits it 1 time, then yes, it's a function. If it hits it more than 1 time, 2 times, then no, it's not. So do you see this? If I draw a vertical line anywhere in this graph, it touches it 2 times. And so that means that no, this is not a function. Let's go ahead and do all 3 of them, and then I'll do domain and range. This one, if I draw a vertical line, it touches it 2 times. No, it's not a function. But you see here, no matter where I draw the vertical line, it's only going to touch it 1 time. So yes, that's a function. So checking if a function is pretty easy with graphs. You just lay your pencil on it, and if it touches it twice, then it's no. And if it touches it once, then it's yes. But let's look at domain and range on these other problems. So remember, domain means your X values and range means your Y values. So you do have to remember, this is your X axis and this is your Y axis. And do you see that X goes between -3 and +3? I didn't leave myself much room. Let me do this in blue so it kind of distinguishes itself. Oops. So my domain is going to be from -3 to +3, because you see that's your domain right there. Oops, my pen's running out. And my range, just having a bad day today. Let me go back to my red pen. My range is also from -3 to +3. So you're looking at where your graph is has values on the x-axis and where it has values on the y-axis. So you see down here, it's not part of the graphs. It starts at -3 and it goes to +3 this way, and it starts at -3 and it goes to +3 that way. Now when we look at this one, do you see there's nothing out here? So when you're traveling along your x-axis, the first place you have anything, that's supposed to be 0 right there, is at 0. So here the domain is from 0 to infinity, because those keep going on. It keeps going on forever out that way. But you see, when you're on the y-axis, think about these arrows as just continuing on forever and ever in space. So I always say, I want to use my hands because in class I kind of act this out. But if you straighten these two arrows out, do you see that that would be the y-axis? So your domain goes from your range goes from -infinity to infinity, because there's arrows on both of these sides. And if you flatten that out, that would be the y-axis. Then your range is -infinity to infinity. This last one, do you see there's nothing down here? So when you, well, let's look at domain and range. Let's do domain first. So when you look at your two arrows, if you flatten that out, that would be, if you laid that I'm sorry, it's a U, and if you flattened it out, I know it's hard for me to do it without using my hands, it would be on the x-axis. So that means on this one, your domain is negative infinity to infinity, and your range, oops, I already wrote that. When you look at your y-axis, there's nothing down here. Your y starts right here and continues to infinity. So your range is 0 to infinity. We do a few more, and then we'll go look at the ones on the worksheet. And then the last way to find function is just by looking at an equation. So these are three equations of a line. And remember I told you that with a line, it's always negative infinity to infinity, and lines are always functions with one exception. And so if you look at this, if you graph this, you would just go to 5 on the y-intercept, and then your slope would be 2/1, regular line. So yes, this is a function, and domain is negative infinity to infinity, range is negative infinity to infinity. This one, even though it's a fraction, it just has a 3 on the bottom, and you could rewrite that as x/3 minus 4/3. That's just a normal line. You would just go to -4/3 on the y-axis, and then go up 1/3. So normal line. So same as that one. Yes, domain negative infinity, range negative infinity. But when you look at this one, now we have a variable on the bottom. And remember so pretty much domain and range is always negative infinity to infinity unless you have a fraction. And if you have a fraction, you can't have 0 on the bottom because you can't divide by 0. So do you see, if you looked at the bottom, what would make that 0? If you let x minus 1 equal 0 and move your 1 over, x would equal 1. 1 is what you would put in there to make it 0. So really you want to say x cannot equal 1. So x can be any other number in the world, but it can't be 1 because 1 would make that a 0, and 3 divided by 0 is undefined. You can't graph that. If you were to graph it, you won't have to do that in this class, but in college algebra, it's what's called a piece function. It would be like a line with a hole in it. But we're not going to graph it in here. We're just going to give our domain and our range. So, but this is still a function. Do you see that nowhere does the graph touch? If you draw a vertical line, it won't touch it twice. So it is a linear thing. So yes, it's a function, but my domain and range is just going to change. Now, since x cannot equal 1, that's our domain. So our domain can go from negative infinity to 1, and then it has to stop, and then you do union 1 to infinity. So it's like it goes up to 1, and then it hops over it and keeps going. And so this is the symbol for union. I think we talked about that in the last video. But then range can be negative infinity to infinity because it keeps going on forever and ever. So when you have a linear function, it's always a function, and the domain is negative infinity to infinity, and the range is negative infinity to infinity, unless it has an x or a variable on the bottom. And then whatever makes the bottom 0 is what that domain cannot be. Okay, so let's stop right there and look at our worksheet. We'll come back to these note sheets. So this is the practice problems that you downloaded today. So just want to make sure you know how to do all of them. So here, you just look to see if your x value repeats, and if it doesn't, then you write, yes, it's a function. Here, I'll do the first one of each one. Yes, this is a function, and then the domain on that one is 5, 3, 4, 7. And the range on that one is 1, 2, 9, 6. And you can write these on a separate sheet of paper if you want to. Here we've got our Venn diagram. You see that all of the it only has one point coming off of each other. So yes, that's a function. This is your domain. This is your range. This one, domain, range. But no, this one's not a function because all of those x's are the same. So it's not a function. Same thing with this one. All of the x's are the same, so it's not a function. And you would just list your domain and range. Then we look at the graphs. Remember line tests. Yes, that's a function. No, that's not a function because you see it touches twice. Not a function. Whoops. Yes, a function because see it just touches it once. Not a function. And then you list those domain and ranges. And then these next 4, remember all of them are regular lines. All of these are just linear with negative infinity, infinity, except for this one. This one cannot be 4 because you see if you put a 4 in there, it would make it a 0. Okay, now let's look at 7.4. This up. And I'll have the answers to this work, the practice problems on the website so you can download it. Okay, so now if we know it's a function, then that means whatever your x is, you're only going to have one thing come out for y. And so when we look at this one right here, just realize this is a mistake here. This is a G. Should be. So this first one, we're saying f of x is equal to negative 2x plus 1, and g of x is equal to negative x squared plus 2x minus 1. So when you know something's a function, you can write it in this form, f of x equals y. So you kind of want to remember this right here, that f of x and y are the same thing. And so if this is your x, since this is f of x, that means this is your x, and what comes out when you do that function is what's going to be your y. So because it's f of x, we're going to use this one. So we're going to say f of 0 equals, so we're going to use this negative 2x plus 1. But instead of x, I'm going to put in a 0. So this becomes a negative 2 times 0 plus 1, which is just 0 plus 1, which equals 1. So your answer really is f of 0 is equal to 1. So it's like you're plugging this number in for x, and you're getting the answer there for y. But this next one, I changed it to g because I want to try this one. This one says g of negative 1. So that tells me I'm going to use this formula. So g of negative 1 is going to equal this negative x squared plus 2x minus 1. And then for every x, we're going to put in a negative 1. So be careful with your negatives here. So it's a negative parentheses negative 1 squared plus 2 times negative 1 minus 1. Negative 1 squared is a positive 1, but don't forget this negative outside. This one was on the test last year, and most people missed that negative, but that negative's still sitting out there. And then 2 times negative 1 is negative 2, and then bring down that negative 1. And then negative 1 minus 2 minus 1 is negative 4. So g of negative 1 is equal to negative 4. Let's try f of 3. So again, because it's saying f, I'm going to use this one. So f of 3 is going to equal negative 2x plus 1. And I'm going to put a 3 in for x that time. So negative 2 times 3 is negative 6. Negative 6 plus 1 is negative 5. So do you see that f of 3 is equal to negative 5? Okay, but then I want to look at, I didn't want to redraw, well, we'll look up here at these. So the next part of your worksheet is going to say, for the function, find f of 2 and f of negative 1. And so let's go back to these I drew earlier. Okay, found one that works. So if I wanted to find f of 2 here, whoops. So remember, I'll just rewrite it up here, that f of x is equal to y. So if I want to find f of 2, this is my x, and so what it equals would be my y. So when I look at this set of ordered pairs, here's where x is 2, so what does y equal? 4. So f of 2 is equal to 4 on this set of ordered pairs. Let's look at this next one. If I said f of 1, well, here's the whole point of why this is not a function. If I said what's f of 1, it could be 3 or it could be 5. And so that's why this one cannot be a function, because you have 2 answers that could work for whatever the x value is. So this will only work for functions. So this one's a function. What's f of 1 on this one? And when you have a 1, your y is 3. Let's do this one. Let's ask, what's f of 4 on this one? Well, here x is 4, and when you follow your 4, where does it go to? 7. So f of 4 is 7. Let's do this table right here. I'm sorry, this is all mixed up in it, but what's f of negative 1 on this one? Well, here's negative 1. When f is negative 1, your answer is 6. Okay, and I don't think, yeah, that's all you have to do on those. Okay, so this last part is telling you to graph and give the domain and range. So really this is no different than what we've been graphing all along. The only difference is now these are all functions. So when it says f of x is equal to something or g of x is equal to something, all it's saying is that it's a function. And so remember that f of x is equal to y. So when you see something like this, this is really just the same as saying graph y equals negative 3x plus 1. This is the same as y equals negative 1/2 x plus 2. And this is the same as y equals 3. So they're really now just like the graphs we graphed in 7.1. And so let's look at this one. So it's in slope-intercept form. So we go to our y-intercept is a positive 1. So we're going to go to positive 1 and draw a point. Then we look at our slope is negative 3. We need it to be a fraction, so we put it over 1. And so this is telling me to go down 3 because it's negative. So from here, down to 3, and then to the right 1. And there's our line. And it wants you to give domain and range. So just remember, domain is negative infinity to infinity. Range is negative infinity to infinity. On any regular line, that's what domain and range is. So the same thing as this one. F of x really just means y equals. So this is my y-intercept is 2. And it's a negative 1/2. So that tells me I go down 1 and to the right 2. If you're lost on graphing, you need to go back and watch the 7.1 video. Domain is negative infinity to infinity. Range is negative infinity to infinity. And then the last one, g of x equals 3, kind of throws you off, but just remember g of x is the same thing. This is just saying y equals 3. So you got to remember this is your y-axis. So you go to 3 on the y-axis and draw a perpendicular line. Now, domain and range is not going to be the same as these. It's not both negative infinity, infinity. Remember, y is your range. So your range is just 3, and your domain is negative infinity to infinity. I mean, again, I go over those in greater detail in 7.1. Okay, so now you're ready to do the practice problems on this worksheet, and I'll give you the answers so you can check yourself, and just email me if you have any questions.